Today I'm going to be doing some past paper questions on the quadratic function, also known as a parabola. These particular past paper questions are coming from the grade 11 GDE paper, so it's suitable for grade 11s. However, matrics, you also need to be able to work with a parabola. In matric, however, we do add calculus, which I'll be doing in future videos. For now, this is just going to be talking about the parabola or the quadratic function from grade 11 level to matric level. What I want to start with is I want to start with the formula so that you're comfortable with what it looks like and with what each variable stands for, because that's important. So you'll see the formulas are going to come up on the screen, and we have two formulas for the quadratic function. The quadratic function can either be written in the form y equals ax squared plus bx plus c, or it can be written in the form of y is equal to a into x minus p all squared plus q. Now, the two different forms determine what the different letters stand for. So depending on what form you get it in will determine what you do with it. Remember, whenever you're working with quadratic equations, quadratic functions, quadratic number patterns, it's always the degree is 2. So the degree of the equation will be a 2. So you can see in the formula for quadratic functions, the degree is 2. If we look at the a value specifically, the a value in both of the formulas, the a value determines the direction or the shape of the graph. Remember, the a value is not the gradient of the graph because the graph is curved and you can't have a gradient of a curve. A gradient is of a straight line. So the a value is not the gradient, the a value is the direction or the shape of the graph. If I'm talking about the y equals ax squared plus bx plus c formula, then the c value is the y-intercept. So that's where it cuts the y-axis. That's what we call standard form. So that equation is in standard form. When it's in standard form, we can determine the turning point by x is equal to minus b over 2a. Once we determine the x value, then we're able to substitute that in to the equation to determine the y value, and then we'll have the turning point as a set of coordinates. For the second equation, however, the turning point is already in the equation in the p and the q. So in functions, the p value is the difficult one. But I say difficult, but it's not really difficult because it remains the same in all of our functions. Every time we see a p, we just need to remember this one thing, that from the equation to the graph, the p changes its sign. So if the p is negative in the equation, the p will be positive on the graph, and vice versa. So we just need to understand that. And that comes in with our parabola, with our hyperbola, with our trig functions. The p always changes sign. So if I have the equation y is equal to a into x minus p all squared plus q, that p is the x value of the turning point and the q is the y value of the turning point, but the p will change its sign for the turning point. And then we'll have the turning point as a set of coordinates. Remember, the axis of symmetry of a parabola is the x-coordinate of the turning point. Another thing to note is that when you're working with a parabola either has a minimum or a maximum value. Okay, so it will have a minimum value if it's a smiley face, and it will have a maximum value if it's a sad face. And that you also need to remember. We're also going to complete the square in this video. However, there will be a full-length video on how to complete the square on my channel, so be sure to check that out if you're unsure on how to complete the square. My suggestion, whenever you have a diagram in maths, whether it's functions or geometry or trigonometry, whenever you have a diagram, I suggest you annotate that diagram. So annotation is just making little markings on your diagram, making sure that everything in words is represented on the diagram, and that way you're not likely to forget something later on. The sketch below represents the graphs of two parabolas f and g. F of x is equal to a half x squared minus 8. The turning point of g is c is 2 and 9, and the y-intercept of g is a, 0 and 5. B and D are the x-intercepts of f and g respectively. So the information that we have, we just need to make sure that everything is put onto the diagram. We have C being 2 and 9, and it says that that is the turning point. So I know that the C point over here is the turning point of this graph. The y-intercept of G is A, 0 and 5. B and D are the x-intercept. And at those points, the y value is 0 for both of them. The first question says, show that g of x is equal to minus x squared plus 4x plus 5. So what we need to now do is we need to use the information that we were given in order to finalize our equation as minus x squared plus 4x plus 5. Now remember, whenever a question says show that, you can't use the that in your showing. You have to use something else. So what is the other information that we have? Well, we have the turning point of this graph. We know that the turning point is 2 and 9, which means that if I have the turning point, I know that I can now fill in my turning point equation, which is y is equal to a into x minus p all squared plus q. So we have, this is the p, and in our turning point, the 9 is the q. Remember that we were given the x coordinate as a 2. Remember that if you're given the p, as in you're given the x coordinate of the turning point graphically, you just need to change whatever that sign is graphically to put it into the equation so that it's the opposite sign. So for example, here we are given that the x value graphically is a positive 2, which means that when I substitute that in, y is equal to a into x. So now it was a positive 2 graphically, which means that I'm going to keep it a minus 2 in the formula. If it was a minus 2 graphically, then it would be a positive 2 in the formula. The q value remains positive 9. But when I look at this formula, I can see that I still have an unknown, so I still have an a. So I need to be able to get rid of that a somehow. Now, in order to get rid of the a, I need to substitute in a second set of information. Now, if I look at the graph G, here it is, then I can see that I've already used the 2 and the 9. So I can't reuse that piece of information into my formula. So I need to use a second piece of information. And that second piece of information is what I'm given over here as a is 0 and 5. So I'm going to take a being 0 and 5, and I'm going to substitute that into my equation. So the y value is 5 is equal to a into the x value is 0 minus 2 squared plus 9. I'm just going to quickly show you. So this is the x value. So I replace the x value with the x coordinate, and I replace the y value with the y coordinate. Now you can see that the only unknown I'm left with is an a, so I can simply solve for that. So I have 5 is equal to a into 0 minus 2 is minus 2, and minus 2 all squared is 4 plus 9. So 5 is equal to a times 4, which is 4a, plus 9. Now I'm going to take the 9 across to the other side. The 5 will stay a positive, but the 9 will now become a negative. So 5 minus 9 is minus 4, equal to 4a. Now to get the a by itself, I'm going to divide both sides by 4. So therefore a is equal to negative 1. So now I have a being negative 1. So now I can take everything that I have, put it into my formula of my turning point formula, and then I can multiply it out to get my standard form. Why am I using my turning point formula? Well, because that's the information that I was given. I was given the turning point, because if you think about it, we don't have the b value or the c value. Y is equal to minus 1 into x minus 2 all squared plus q is 9. So y is equal to, I can keep this negative 1 outside the bracket, and I'm going to square out this bracket. So x minus 2 all squared is x squared minus 4x plus 4, carry down my plus 9. So y is equal to, I now take that negative 1 outside the bracket and I'm going to multiply it in with everything inside the bracket. So I have negative x squared plus 4x minus 4, carry down my plus 9. Therefore, y is equal to minus x squared plus 4x minus 4 plus 9 is positive 5. And there I have the standard form that they asked for, y is equal to negative x squared plus 4x plus 5. The next question asks for average gradient. Now remember, average gradient kind of works the same way as normal gradient, except average gradient, because we're working with a curve, that's why we're determining average gradient. Now remember, average gradient is still the change in y over the change in x. So we're going to work with the change in y over the change in x. So the two y values, we're going to find the average gradient between point A and point C. So it doesn't matter if we swap the A and the C around, but remember you can't swap the x and the y around. So the average gradient will be the y minus the y divided by the x minus the x. So the average gradient, 9 minus 5 over 2 minus 0, comes to 2. Remember, it doesn't matter if we have 5 minus 9 over 0 minus 2. We're still going to get to the exact same answer. The next question says, calculate the length of BD. Now, if I calculate the length of BD, I need to first identify where is BD. So BD is this line, it's this length over here. So if I color it in my diagram, remember that a length has to be a positive value. So I have the length between B and between D. What do I notice about B and D? B and D are the x-intercepts of these two respective graphs, which means that if I can determine the two x-intercepts, I'll be able to find the length of this line. The important thing to note is which letter or which x-intercept belongs to which graph. So B is the x-intercept of F and D is the x-intercept of G. We are now going to determine the x-intercept, and remember, for the x-intercept, we're going to let y equal 0. So we're calculating or determining the x-intercepts of the first graph. So we take our first equation, which is a half x squared minus 8. Y is equal to half x squared minus 8, and we make it equal to 0. So we're replacing the y with a 0. Now we're just going to solve this equation. Now there are multiple ways to solve a quadratic equation. We could use the quadratic formula, we could use factorization. I'm going to factorize this in a specific way to remind you of a process that's very important. So we have a half x squared. What I'm going to do is I'm going to isolate that half x squared by taking the negative 8 across to the other side. So I have 8. Now I want to start isolating the x. So to isolate that x from the half, I'm going to multiply it with 2. So if I multiply both sides by 2, I'm going to have x squared is equal to 8 times 2, which is 16. Now I need to square root both sides. So therefore, x is equal to, and this is the process that I just want to remind you of. Don't forget, when you square root a number, you have a positive and a negative answer. You have both values, and you have to remember that. The square root of 16 is 4, so x is equal to plus or minus 4. So that means, therefore, that x is equal to positive 4 or x is equal to negative 4. So what I'm going to do is I'm going to draw some eyeballs. Why on earth am I drawing eyeballs? Because eyeballs are going to remind us to look. Look at what? Look at the graph, because we need to know where each of these 4 and negative 4 belong and which one belongs to B. So if we go back to our graph, we have B here is 0, so that means that b is on the negative side of the x-axis, which means that between 4 and -4, I know that b's x-coordinate is -4. So d is the x-intercept of g, and we are going to let y equal 0. So we've got the equation y is equal to -x squared plus 4x plus 5. So now I'm going to say 0 is equal to -x squared plus 4x plus 5. And I'm going to solve this. So in order to solve this, I want to make my x positive, and in order to do that, I'm going to divide everything by -1. When I divide everything by -1, 0 divided by -1 is 0, is equal to -x squared divided by -1 is x squared. Positive 4x divided by -1 is -4x. And positive 5 divided by -1 is -5. So I have 0 is equal to, obviously I don't need to use the quadratic formula for this. I can just factorize this normally. How do I do that? I look at my last term. My last term is negative, which tells me that the signs are going to be different. So 1 will be a plus and 1 will be a minus. I factorize the x squared and it goes as x. And then I need the factors of 5 when subtracted that give me 4. Now the factors of 5, there's only one set of factors, which is 1 and 5. So I have 1 and 5 that need to go into these brackets. How do I decide which one gets the negative? Well, I look at my middle term. My middle term is negative, which means the bigger number gets the middle term sign. So it's 5 and 1. So we have x plus 1 equal to 0, or x minus 5 equal to 0. If x plus 1 is equal to 0, x is equal to -1. And if x minus 5 is equal to 0, then x is equal to positive 5. So now I have -1 and I have positive 5 as options. If I look at D, if I have -1 and positive 5 as options, I can see that D is on the positive side of the x-axis, which means that D's x-coordinate will be 5, and that actually means that the other x-coordinate will be -1. Now I have B and I have D. B is -4, D is positive 5. So I can get the length of BD very easily. So therefore, BD is equal to, remember that for lengths, we actually have 3 options. We have a vertical length, we have a horizontal length, and we have a diagonal length. Now, if I'm talking about a vertical length, I'm going to work with y top minus y bottom. So either it's the coordinates of the y at the top minus the coordinates of the y at the bottom, or it's the equation minus the equation, whichever you have. Then we have a horizontal line. And what I like to do is I like to say x right minus x left, because that way you're more likely to have a positive answer, and then you're less likely to have to remember that a length has to be positive. For a diagonal length, however, you can't do y top minus y bottom because it's a diagonal. So whenever you have a diagonal length, chances are you're going to either use trig or you're going to use Pythagoras, depending on what other information you're given. But for a diagonal length, you would need the other 2 lengths given, or you would need to calculate or determine the other 2 lengths first. So for BD, we have the right value, which is D, which is 5, minus the left value, which is -4. So that is 5 minus -4, which is the same as 5 plus 4, which is 9. And then just don't forget to put units at the end. So BD is 9 units. The next question says, use the graphs to solve for x if f of x is greater than or equal to 0. So if I'm looking at f of x is my half x squared minus 8. F of x is my smiley face. So I'm going to highlight that. I want to know or use the graph for where f of x is greater than or equal to 0. So what I'm going to do is I'm going to identify where f of x is equal to 0. So f of x is equal to 0 on the x-axis. So if I can see that f of x is equal to 0 on the x-axis, I can then clearly see where f of x is greater than or equal to 0. For the f of x being greater than or equal to 0, it means that it can be on the x-axis, but it has to be greater than or equal to 0. So if I just look at these graphs that I have here, and I'm just going to color it in red. All right, at this point B and at this other x-intercept, which we actually know is positive 4, right? Because in the previous question, we got the two x-intercepts, minus 4 and 4. So we know that that point is 4. Okay, so at minus 4 and at 4, this graph is equal to 0. So where would it be greater than 0? Greater than 0 will be everything above that x-axis. So what does that mean? That means it's all of these values above the x-axis. I'm going to color in green where this graph would be less than or equal to 0. So it would still be at the minus 4 and the 4, but less than 0 would be below the x-axis. We have different ways that this question can be asked. So we could be asked, where is f of x greater than or equal to 0? Where is f of x less than or equal to 0? Where is g of x greater than or equal to 0? Where is g of x less than or equal to 0? Where is f of x greater than or equal to g of x? Where is f of x less than or equal to g of x? So we could have a lot of different ways that these questions could be asked, and all you have to do is you just have to identify what are they asking. And whenever you can identify if they're asking for greater than or equal to 0, the 0 point is the x-axis. So greater than is where is it above the x-axis, less than is where is it below the x-axis. When you have two graphs on either side of the inequality, then you just have to identify where is the graph bigger than the other graph, where is the graph smaller than the other graph, depending on what the inequality states. So the question actually says use the graphs to solve for x. Now remember, if I just quickly just do a side note here, f of x greater than or equal to 0, I could actually replace that f of x with a y. So where is y greater than or equal to 0? And that is actually why we're using the x-axis as our 0 point, right? Because y is equal to 0 on the x-axis. So for which x values will y be greater than or equal to 0? When x is smaller than -4 or equal to -4. And also where x is greater than +4 or x is equal to +4. If I were to write this out as an inequality, I would say that x must be less than or equal to -4, or x must be greater than or equal to +4. Remember, if I had f of x greater than 0 and not greater than and equal to 0, then it would be the exact same answers, except I would just delete the tongue of the crocodile teeth. So that's pretty easy. That's a pretty easy difference to make. The last question says, use the graphs to solve for x if f and g are both strictly increasing. Okay, so f and g need to both increase strictly. So I'm just going to delete all of this extra paraphernalia for a minute so that I can just explain this point to you. So this was -4, this was +4, this was -1, and this was 5. Remember, I just want to quickly just do a little side note over here so that you understand what I mean when I say look. Okay, if I were to look at this graph, I'm going to just use this orange pen and I'm just going to scribble all over these graphs. If I were to look at f, the graph of f, I would be able to see based on the graph that it's a smiley face, that it's a happy graph, and that the a value is positive. And in the equation over here, I can see the a value was 1/2, so that is positive. So like I said, I'd be able to see it. If I look at the graph of G, I can see based on the graph that the a value is negative. It's a sad face graph. There are no eyeballs. That's a very sad graph. All right. So we also know that the equation of this graph is -x² + 4x + 5. So -x², so the a value is -1. Also, what we would be able to see is once we had calculated B's x coordinates of -4 and 4, we would have been able to know not the value of D offhand, but we would have been able to know that D needed to be bigger than the number positive 4 because D is after the positive 4. The question says, though, that both the graphs have to be strictly increasing. So increasing is obviously going up, right? So increasing is going up, decreasing is going down. If I wanted to know where both of these graphs are increasing, I would start by identifying where they are increasing individually, and then I can say where they are both increasing together. So how do I know if it's increasing? It's going up. So what I can do is I can just take my pen. Also, it writes very, very skew, so just bear with me. So what is happening to my pen? Well, my pen is currently going down. You can see the orange line is going down. It's still going down. It's still going down. It's still going down until the turning point, in which case my graph is now increasing. So I can see now the green is an increase. If I look at G, I actually start with an increase. So I start and look, it's going up, going up, going up until the turning point. And then at the turning point, my graph is now decreasing or going down. So now what I need to be able to do is I need to be able to identify where both graphs are increasing. So I can see over here, this graph is decreasing. If I look over here of my graph G, what I've just scribbled over in pink, while that graph is increasing, this graph is actually decreasing. So that eliminates that part. If I look over here, you can see I'm scribbling in pink. The graph of F is increasing, but the graph of G is decreasing. So where are they both increasing? Well, they're both increasing from the y-axis. We can see that both of the lines are green from the y-axis, so from where x is 0. Because it says for which x values are both the graphs increasing. So from where x is 0, these two graphs start increasing together. Well, how do I know that? Well, because I color coded them and I can see that they're both green at that point. However, something happens at the turning point of graph G and it starts decreasing. So that means that F will still be green, but G will now be orange. So that means that the part where both of these graphs are strictly increasing is between the y-axis and the turning point of graph G. So that means that the answer would be between x is 0 and x is 2. Now you can see I haven't put in the crocodile teeth yet, the inequality sign, because I just want to talk about it quickly. For which values of x will both these graphs be strictly increasing? So we know that x has to be between 0 and 2. Now, at the point 0, this graph here, the graph of f is at the turning point. So at the turning point, it's also known as a stationary point. So as in, it's neither increasing nor decreasing at the turning points, which means that that point of 0 is the turning point of the one graph. So it's not increasing or decreasing at that turning point. And then 2 is the turning point of the second graph, which means that it's not increasing or decreasing either, which means that the crocodile teeth will not have a tongue. So it's just that x will be between 0 and 2.